All right, ladies, in this video, we're going to go through the extended response questions for exam 2 and just focusing on parabolas. So we'll do a different video for the other topics just because it will be an extremely long video otherwise, and you probably will need a break from me after 20 minutes. So let's aim to get this done in 20 minutes and then you can watch the other videos at another time. Okay, question 1. Tom and Colin are playing a game that involves kicking a soccer ball over a 290 centimetre wall. Tom is 4 metres from the wall on one side, Colin is 6 metres on the other side. Tom kicks the ball off the ground and it lands at Colin's feet. The flight of the ball is modelled by the equation h equals blah, 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 where h is the height above the ground in metres and x is the distance along the ground in metres. Assume that the wall is on the y-axis. Okay, so lots of information there. The important thing to note is we've got Tom's distance and Colin's distance in meters, yet the wall is in centimeters. So let's just convert that into meters. So it's going to be 2.9 meters because h and x are in meters. So h is the height in meters and x is the distance in meters. Okay, so we have to have everything in the same units. And when you think about it, if we were working with a wall that was 290 meters tall, that's a pretty big wall. And I don't think Tom would be able to kick the ball over it. All right. So our equation, which I might highlight in yellow, just because it's a lighter color. Here it is here. This is in factorized form. So the good thing about this is I can see straight away what the x-intercepts are. So remember your x-intercepts are when h equals 0. Okay, so we're using h, not y in this case. And it's a good idea to get into that habit of using the variables in the question now in year 10, because when you get into methods next year and in year 12, you're going to have, if you don't use the variables given, you're going to get things wrong. Okay, so just make sure we stick with what the variables are. Okay, so what we're going to have is negative 1 on 8, x plus 4, x minus 6 is equal to 0. Now you can just do solve on your calculator. Okay, so let's quickly do that. Now, I was doing this question before. Yes, this is actually the third time I've started this video. So let's hope that this is the third and final time. Algebra. So solve, just typing in your equation. So negative 1/8 x plus 4 x minus 6 and equals 0, comma x. And you can see there it's negative 4 and 6. So I could see that because it was in factorized form, but if not, remember this is a CAS active exam, so you can use your calculator. So using solve. All right, so coordinates for Tom. Tom is 4 meters, so his coordinates are going to be the negative 4 and 0. So remember coordinates, you've got to give your x and y, not just say negative 4 because that's not coordinates. And 6 meters for Colin, so he's at 6, 0. The top of the wall, which we've already realized is at 2.9 meters. Now that is on the y-axis, so that means x is equal to 0, so that's the coordinates for the top of the wall, and the bottom of the wall is at 0, 0. Okay, so what we've got here is we're eventually going to have to draw it. So here's Tom at negative 4. Here is Colin, and I'm just going to do the wall in maybe yellow. Okay, so the wall goes all the way up to 2.9, so there it is there. Now, when I did this video before, I did make 2 mistakes. One was related to the turning point, but the other one was assuming that this was the y-intercept, and I didn't actually go back and just say, oh, I made that mistake. I'd gone too far. I think it was about 13 minutes in and I was like, nah, start again. So just be careful not to make that mistake. And my dog, it's probably a good thing that I didn't actually keep going with that video because my dog kept grooming herself and she was being very, very noisy. So I kept telling her off. So it was a bit distracting. Okay, the valid values of X. So X can go from Clancy at -4 to Colin at 6. So X can be anywhere between -4 and 6. Now, the ball can't go below the X axis, so it's got to stop at these points, okay? It can't go below because then it'll be underground. And, you know, if it was a really heavy ball, it could probably go underground, but if it was a really heavy ball, I don't think Tom or Colin could actually throw the ball. Okay, so what we've got so far is just the x-intercepts. We don't know whether it can go across the wall or not. So we need to find now the y-intercept and the turning point. So I'm going to show you both how to do it by hand and on the calculator. So let's do the y-intercept first. So the y-intercept, you let x equal 0. So we're going to have y equals -1/8, 0 plus 4, 0 minus 6. So y equals -1/8 times 4 times -6 is -24. So negative times a negative gives you a positive, which we want. We want it to go over the wall. And then 24 divided by 8 is 3. So your y-intercept is there at 3. Now your turning point is halfway between your x values. So sometimes you can actually read it straight off there. I can see it's going to be 1, but if you can't see it, we can say, well, it's at x equals the halfway point. You just need to add your two x-intercepts together and divide it by 2. So -4 plus 6 is 2, so 2 over 2 gives you 1. And then to get the y-coordinate, we're going to have -1/8, 1 plus 4, 1 minus 6. So y equals -1/8 times 5 times -5. So we're going to have 25 on 8, which is 3 1/8, which is 3.125. So we're at 1. 3.125 is just probably a little bit lower than that, but that is probably good enough. Now remember, parabolas are symmetrical, so this point here, our y-intercept is going to be the same as this point here, which will just help us when drawing it. Okay, now let's actually sketch it. So just drawing your dots best you can. You need to go through that turning point and the y-intercept. Okay, we do need to label where Tom and, what's his name, Colin. Here's our turning point, so I'm just going to label that. It's 3, 1.125. What? 3.125. How did I do that? Sorry. 3.1.125. Silly, silly, silly. 3.125. You could write it as 3 1/8, or if you want 25 over 8, that's fine. Now, let's do all this on the calculator, because remember, this is a tech active exam. So first of all, you can go to complete the square. So complete the square will put the equation in turning point form. So at the moment, it's in factorized form. When you're when you're doing anything on your calculator, if you've already put the expression in, like what I'm highlighting now, you can just press shift, so above the 7, just like you do on a normal keyboard, and highlight it, Control C. So now and then copied it, and now I've pasted it. Okay, so I don't have to type it in again. And just do comma X. Okay, so what I've got here is it's in turning point form. The thing is, the calculator doesn't start with a negative, so your value of K is actually at the beginning instead of at the end. So it does look a little bit weird, but 3.125 is K and H is 1. So there's your turning point there. You can also get your turning point by going to calculus function maximum. And, whoops, actually make sure your calculator correct. Okay, so let's do that again. Calculator function maximum. Now, because I've already copied the expression, I can just do Control V, so paste it again, comma X, and there's the X coordinate of the maximum. So if we want to get the Y coordinate, we can just go put our expression in again and Control equals, this sign here is given that X equals 1, and there's your Y coordinate of the turning point. Another way you could do it is to actually draw the graph. So let's go here. Wonder if it's going to let me paste it. Beautiful. Put it in. There it is, your turning point. So we go Menu, Analyze Graph, Maximum. So we just go to the left, to the right. Now you can see it's, what am I going to say? It has put the coordinates to 2 decimal places, which is very annoying because I know it's not 2 decimal places, it's 3.125. So if you wrote 3.13, you're actually going to get it wrong. Okay, so I would use these other methods as opposed to using this. Now, I might just double check while we're here, change the settings. Let's see if I can change it to like 12. I wonder if that's going to change it for me. No. Yeah. So calculator is better than the graphing. The graphing, you know, it's rounded it. I don't know how to change it. I think sometimes it works and sometimes it doesn't. It's really frustrating. I could play around with it. Let's just have a look. Yeah. Yeah, I don't know. So sorry, girls. I've just had a quick look. I paused to have a look. So I would just do this screen, the calculator, as opposed to graphing, but graphing does help with other things as well. So if a question comes up with that, I'll show you on the calculator. Okay, so we got, oh, actually, we only did the turning point. We haven't got the y-intercept. Okay, so to get your y-intercept, you can just go to Trace, Graph, Trace, and you'll notice down here it says the function 0. So there it is. 0 is your y-intercept, 3, 0, 3. Now, if you wanted to find another value on the graph, you can just put your x coordinate in. So if I wanted to know what it was when x equals 2, there it is. It's at 2, 3. Okay, if I wanted to do x equals 4, just type 4, and there it is, 4, 2. Okay, so the calculator's good like that. All right, question D, after we've finished that. So we labeled the wall, I drew the wall, Tom, Colin, and the maximum height. Explain and justify whether or not the ball would clear the wall. Okay, so it will clear the wall. Yes. Actually, I was thinking about this before when I was drawing the wall. It depends how wide the wall is. I mean, if the wall was very wide, it wouldn't. We're assuming that the wall is very thin. Yes, basically because the wall is 2.9 meters and the ball crosses the wall, the top of the wall or above the wall, at 3 meters. That's probably good enough. You could say there's 10 centimeters between them. All right. Colin can head the ball if it reaches him at a height of 1.5 meters off the ground. How far from the wall should he stand to head the ball? I think headbutt the ball. Give your answer correct to 2 decimal places. So at 1.5, which is here, and we're doing Colin. So we want to know what this point is here. Okay, so what we can do, we know that's at y equals 1.5. Okay, so let's do the tech free and then we'll do the tech active. So we just need to substitute that into our equation. x minus 4, no, it's x plus 4, x minus 6. Okay, so 1.5, I'm just thinking. All right, so let's bring that 1/8 over. So I'm going to change the 1.5, sorry, to 3 over 2. So we're going to multiply that by -8. Okay, so I'm just solving for x. So 3 over 2 times -8. So 8 divided by 2 is 4. 3 times 4 is 12. So -12. Oops. X minus 6. So we can split these two up. So x plus, actually, no. Let me just think. Yeah, this is going to be complicated to do by hand. So let's keep going. I'm going to expand this expression. So x squared minus 6x plus 4x. So it's going to be minus 2x minus 24 equals -12. So then we're going to have x squared minus 2x plus 12. So minus 12 equals 0. Now, two numbers when multiplied give you -12 and when added give you -2. So the problem with this is we're going to have to use the quadratic formula. And I don't have enough space here. Okay, so if this was a tech-free exam, I'm going to stop here because I just don't have the space. But tech-free exam, you would use the quadratic formula to work out what this point is here. But because we've got a calculator, and I might actually just write here, use quadratic formula. All right, so let's get on the calculator. So remember before I was saying we could type something in and we get the points. So if I typed in 1.5, that's actually finding x equals 1.5, not y equals 1.5. So what you could do is do solve. Okay, so remember 1.5 equals, oh, and I might still have got it in there, beautiful, comma x. So you can see you've got two solutions, and let's just see what it wants, 2 decimal places. I might just write on over here on CAS, just because some people won't watch this video and would wonder. Okay, so we've got -2.61, so that's on the other side, on Tom's side. So on Colin's side, it's 4.61. Let's just go back. So if I go back up here, let's just check our answer. Okay, so 4.61 is somewhere around here, and you can see that that's correct. Okay, so if I got an answer that wasn't between 4 and 5, I would probably say I've gone wrong somewhere. So on CAS, x equals 4.61, so stand 4.61 meters from wall. Now, if you use the quadratic formula, obviously you're not going to get it in decimal places. You would just use the exact value. Okay. Now, this question is worth 2 marks. So you would need to show this. Okay, just that you know what to type into the calculator, and then 4.61 meters. Now, if you wanted to do the graphing, let's go back to our graph. Tab to put in another equation. We wanted y equals 1.5 or f of x equals 1.5. There it is. This is the intersection we want. So we can just go to menu, analyze graph, intersection. So to the left and then to the right. And let's just move this coordinate so we can see it, 4.61. But again, remember, it is rounding it, so it's probably better that you go to the calculator screen. All right, let's move on. Question number 2. Actually, I might have a quick drink. All right. We did do a similar question to this when we did parabolas, but that was back in, I think, July or August. So the diagram shows a masonry arch bridge of span 50 meters. The shape of the curve ABC is a parabola. AC is the water level. Okay, so take A as the origin and the maximum height of the arch above the water is 4.5 meters. So maximum, take A as the origin and the maximum height of the arch, okay, which is here. Okay, so that's 4.5. This is 0. An equation for the curve of the arch where y is the height of the arch above AC and x is the horizontal distance from A can be written as y equals, so this is your turning point form. State the values of h and k. So x is the horizontal distance from A. Okay, so that changes because x is a variable. So state the values of h and k. So remember, this is your turning point. H and K are your turning point. So we want to know the coordinates of this point here. We already know the y coordinate is 4.5. And the x coordinate, because the distance between A and C is 50, that means x is just halfway, which is 25. So our coordinates are going to be 25, 4.5. So h equals 25, k equals 4.5. Okay, show that A equals negative 9 on 1,250. So with our turning point form here, for a show that question, okay, don't go substituting the answer in here. The reason you're given the answer is so you can use it later on. Okay, so we have to show how we can get that answer. So let's write our equation. Y equals A x minus h, so x minus 25 squared plus 4.5. Now we need to substitute in another point. Now, 2 points we haven't used. We haven't used 0, 0, and we haven't used 50, 0. You can use either one, but you can't use the turning point because we've already used it. 0, 0 is easy peasy Japanesey, so let's use that one. So sub in 0, 0. Okay, so we're going to have 0 equals A, 0 minus 25 squared plus 4.5. Okay, so let's tidy things up a little bit. All right, so we're going to have A times negative 25 squared. So 25 squared, just on the top of my head, actually I'm just doing it on the calculator beside me, is 625. So A times 625 plus 4.5. Okay, let's bring that 4.5 over. So it's negative 4.5 equals 625a, then divide both sides by 625. Now, we shouldn't have a decimal in a fraction. Okay, so basically what has happened here is we've multiplied the numerator by 2 and the denominator by 2. So A is equal to negative 9 on 1250. Now, on your calculator, and I assume this question is worth 2 marks, which it is. Okay, so we can do this on the calculator, but you need to show this. Okay, and you also need to show, where are we? This bit here. Okay, that you're substituting in the point. So you probably should then also write in this. Say what you're doing. All right, so on your calculator, all you need to do is use solve. All right, so let's get the CAS, solve. Let's see if I can remember it. What was it? A, x, that was 0, wasn't it? 0 minus 25 squared, and then plus 4.5, oops, equals 0. No, equals 0, sorry, comma x. Okay. It's saying false. What we need to do actually, can I just check my equation? All right, I don't think it likes that A next to that bracket. That's usually, oh God. All right, I can see where I went wrong. I know I shouldn't get false. So let's highlight it. Okay, so my square is around the wrong thing. It needs to be around the the 0 minus 25. Just make sure that's right now. Probably got too many brackets there, but that's all good. Oh my gosh, stop doing it. There we go. All right, so it's put it in decimal form. I can assume that it is the right one, but we can just go to Document, Settings. So you should be interchanging between these, approximate, exact. I'd probably always leave it in exact mode, but sometimes approximate's good. Okay, so there we go. A equals -9 on 1,250. Okay, at what horizontal distance or distances from A is the height of the arch above the water equal to 3 meters? Give your answer correct to 2 decimal places. So at what horizontal distances from A is the height of the arch? Okay, so we want to know 3 meters. So let's say 3 meters is around here. Okay, so we're basically finding this point and this point here. All right, so let's, do it by hand. We're going to sub in y equals 3. Now, I'm very conscious of the time. We're already at 27 minutes, so I'm going to quickly do it on the calculator. Okay, so again, we can go to solve. Now, I know that A is -9 on 1,250, so I can type that in. Should just put the negative in first. And move. Okay, x minus 25 squared plus 4.5 equals, now we want it at 3 meters from memory, comma x. So there's our two solutions, but it does say, where are we? Two decimal places. So let's go back. So we can highlight it and just go Control Enter. We'll put it in decimal form. So we're at 10.57. So remember, we've got to round. So 10.57. I'm not going to remember, so I'm going to have to scroll back. So at x equals 10.57, and just want to make sure that's the variable it's used. X, good. What's the other one? 39.43. Okay, what is the height of the arch at a horizontal distance from A of 12 meters? Give your answer correct to 2 decimal places. So this time x is equal to 12. So if you're doing it by hand, you just put x equals 12 into your equation, but let's do it on the calculator. So I'm just going to highlight this again. This time we're solving for y, so I'm going to put y in. If you want to put h in, that's fine. And x is 12. Okay, so let's just press enter. Then we get a fraction, so let's put in decimals, so 3.28. And I just realized I used y previously, so let's just change that to h. It's because I said at the start to use the variables given and I wasn't. Okay, h equals 3. Just make sure I copy that down correctly. 3.28. Good. Okay, a floating platform 20 metres wide is towed under the bridge. What is the greatest height of the deck above water level if the platform is to be towed under the bridge with at least 0.3 metres horizontal clearance on either side? All right, so let's go back to this. This is 20 metres. And then we need a clearance of 0.3 metres each side. So 0.3. Okay, so we've got to have 0.3 each side. So your x coordinate, we're going to be doing, oh my gosh, I just had a blank. Okay, so halfway is 25. So we're going to be 25 minus 10.3. Okay, so half of this is 10. And we're going to add the 0.3, the 30 centimetres. And the other side is going to be 25 plus 10.3. So we're going to be at 35.3 and also, what is that, 14.7. Okay, so we can substitute in, I just want to make sure I've done that correctly, 14.7, 35.3. 35.3. So on the calculator, let's go back. We can just go to solve again. This time x is 14.7. All right, so it's going to give me a fraction, so I'll just do that. So 3.74. And then x equals 35.3. Let's highlight it again. Scroll, scroll, scroll. 35.3. Now, you can press enter now and then press enter again, or just control enter, we'll put it in the decimals. Oh, what did I do? Oh, it's the same height. Ah, okay, silly me. So getting back here, yeah, so you're going to have the same height. What did I have? 3.74. All right, I did have to just check that because that diagram just really threw me because that is definitely not to scale. I've just given it some more thought. I really feel like it's fine. Yeah, it looks okay. All right, I'm going to move on just because, yeah. All right, let's move on to question 3. A dolphin dives out of the water in a path given by blah, 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 where h is the height. At what times is the dolphin at water level? Okay, so your water level is when h equals 0. All right, we've done a few of these by hand, so I'm just going to quickly do it on the calculator. So h equals 0. So we're on the calculator, we're just going to have 0 equals negative 2t minus 3t minus 3. Okay, I might make this a bit smaller so I can actually see the question. Solve 0 equals negative 2t minus 3t minus 3, comma x. All right, what did I do wrong? Now, sometimes, no, it's done that correctly. Oh, silly me, t. Okay, t equals 3 on 2 or t equals 3. So 1.5 meters and 3 meters. How long is the dolphin in the air above water for? Okay, so how long is the dolphin in there? Okay, so that's just, no, what am I doing? T is not the distance, it is the time. So 1.5 seconds and 3 seconds, sorry. So 1.5 seconds to 3 seconds, so it's in the air for 3 minus 1.5, which gives you 1.5 seconds. Evaluate to 2 decimal places the maximum height above the water the dolphin reaches. So the 1.5 and the 3 are your t-intercepts. So you can add them together, divide it by 2 to get your x-coordinate. So 4.5 divided by 2 gives you 2.25, and then you can substitute that back into your equation. But remember, we can just use our calculator. So let's go back, and I'll make it bigger now because I've got the equation on there. I do prefer completing the square just because it is one step less. But if you have trouble identifying the turning point in completing the square, use one of the other methods. So remember, we just need the expression, all right, and then comma t, because I've written t. So it's now in turning point form. So your turning point is at 9/4, 9/8. Now it does say two decimal places, so let's just go to Control Enter. All right, so 2.25 and 1.125. So the maximum height. I don't know why it said to 2 decimal places, because 125, I mean, it's only 3 decimal places, so let's do 1.3 meters. All right, on the set of the axes below, sketch the graph of h against t, clearly labeling the turning point. Okay, so we've got t, got h. All right, here is 0. The dolphin goes out at 1.5 and comes back in at 3. So let's just do 1, 2, 3. So there's one x-intercept. What was the other one? 3 on 2. So 1.5. Yeah. All right, and your turning point was at 2.25, wasn't it? Which is here, and 1 point. That's a bit annoying because I'm going to make that 1. 2.25, so you're up about here. All right, so there's my parabola. Now just keep going down. Obviously, the dolphin does go in the water. It's not like that ball going underground. And it's got it long enough so we can actually do the y-intercept. So, oh yeah. What is it, H? Oh, I can't control. Let's just go back. Highlight. Copy. Paste. Oh. What happened there? What are you doing? Okay, so we're doing the y-intercept. So that's when t is 0. Oh gosh, what did I do wrong? Equals, oops, comma y. So -9. All right, so now obviously my scale's not, yeah, I should have done that. -9 is going to be all the way down there. All right, but you get the gist of it. Not that I think the dolphin would go that far down. Okay. Let's label. So this is 2.25. I would rather leave it as 1.125, to be honest, because it does stop at 3 decimal places. But if you're at 1.13, that's fine. All right, and writing it with the coordinates. So this is 1.50, and this one here is 3, 0, and then down here we had 0, -9 for our y-intercept. Oh my gosh, another question. During a fireworks display, a rocket is fired into the air from the ground. The rocket follows an inverted parabolic path, blah, 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 where h is the height of the rocket in meters, t seconds after being fired. Find the maximum height. Okay, so it's in expanded form. So if we're finding the maximum height, let's just use our calculator. And I might make it smaller so I can actually see the equation. Okay, so I'm going to complete the square again. I find it's a lot easier. Sorry, algebra, complete the square. So 14, using t again, t minus t squared, comma 0, comma t. All right, so the value of h is 7 and k is 49. So 749 is your turning point. So the maximum height is 49 meters. Now it doesn't say when, but it's at 7 seconds. Now that's worth 3 marks. Okay, so I would probably just make this a 1 mark question, but because it's worth 3 marks, you would have to probably show how to complete the square, or you could factorize it. So, and then find the turning point that way. All right, what I might do is, just because I think factorizing is probably going to be the easiest option, so take out t as your common factor, and then I'm left with 14 minus t. Okay, so I'm just factorizing this. So that's going to be, so your t-intercepts, let h equal 0. So t equals 0, or 14 minus t equals 0. So t equals 14. Halfway between them, so the turning point is at t equals 0 plus 14 over 2, which is at 7. And then you can just substitute into h. So h equals 14 times 7 minus 7 squared. So h equals 14 times 7. Now I'm guessing it's 98, just because I know what the answer is. Let's just double check. 98, good. 98 minus 49, and h equals 49. So your turning point is 749. But as we said before, there's your answer there. But because it's a 3 mark question, you should probably show some working, but also it's a CAS active exam, and I've taken note on the CAS active exams that if it can be done on the calculator, it's not going to be worth 3 marks because it's CAS active. We're encouraging you to use your calculator. The rocket is programmed to explode when on its descent it reaches the height of 45 meters. How long after being fired does the rocket explode? So we want to do the h equals 45. So on its descent, so that's when it's coming down, because you're going to get 2 solutions for it. So let's just put in 45 into our equation. So 45 equals t 14 minus t. Oh, I could have used, sorry, let me just go back. The expanded form is better. What was it? 14t minus t squared. Okay, so let's put everything on the same side. So t squared minus 14t plus 45 equals 0. And we're just solving for t. So if you were doing that by hand, you could do 2 numbers when multiplied give you 45 and when added give you negative 14. You can use the quadratic formula. I'm just going to use the calculator. So solve. I've already got the expression here, so I'm just going to highlight that. Control copy, paste. Oh, why? It's not cooperating. There we go. And all right. Hope it works now. Control C. I think it's tired. It needs to go to bed, like me. All right, equals 45, comma T. All right, 5 or 9. Oh, I could have easily factorized that. All right, so basically that means T minus 5, T minus 9, if you're doing it by hand, equals 0. So T equals 5 or T equals 9. Now we want to do it on the descent, so it's at 9 seconds. Okay, because 5 seconds is when it goes up and 9 seconds is when it's coming back down again. All right. I wonder if that's the last one. Okay. Long video, girls. I'm sorry, but hopefully it was very helpful. Bye.